have you accepted my file? Two pages of file with 8 figures. Like this. I shared my file through the chat. Chat, please look at it. Chat. Okay, the file, could you accept it?
We already delivered for the student.
Oh, thank you very much.
Yes, you're welcome.
So the content of today's lecture is already sent you by the file with the Indonesian language. Today I start from the chapter 1.4, weak acids and pKa. According to the material with the Indonesian language.
morning.
Can I start my class?
Yes, please.
Yes. So then I start from the 1.4. Weak acid and pKa. Weak acid is very important because many solids and soil solids in the water and soil components such as clay minerals, humus, have weak acid functional groups. Components are weak acid. Then the knowledge on the weak acid is very important for soil chemistry. For example, acetic acid. This is the typical weak acid.
Tapi katanya ini kuliah S2.
Equal to okay, can you read the
Yes, we can
characters?
read.
Okay.
Yes.
Minus slope for both sides. Minus slope for the both sides. Then this is pH. This is pKa. Then finally, so this is a fundamental equation showing the relation between pH and pKa and the ratio undissociated and dissociated bonds. Please memorize this equation. From this equation, here pKa is equal to 4.77. If pH is 4.77, left hand becomes 0, then log 1 is 0, then equal. The dissociation percentage is 50%. When pH is 5.77, plus 1. When pH is 5.77, dissociated species is 10 times more than 4. Then could you look at the figure 1? Figure 1 is a dissociation curve of acetic acid. This curve is very easy, prepared by using this equation. Okay, do you understand? Chemists often say that pKa of when chemists know that pKa of acetic acid is 4.77. It is very easy to understand that 50% dissociation at pH 4.77. Result 91%. Acetic acid at pH 6.77, 91% dissociation. Only from this information we can know about the dissociation ratio of the acetic acid. So the explanation until now is for the ideal solution, but real solution. For example, in 0.1 mole per liter NaCl solution, Ka equal In ideal solution, 1.7 by 10 minus 5, but increase. pKa 4.77 decrease for 4.88. In real solution, pKa increase. Ka increase. pKa decrease in real solution as compared to ideal solution. Then, next, divalent acid, such as carb carbonic acid. Could you look at figure 2? Figure 2 shows the dissociation curve of acetic acid. No, carboxylic acid, H2CO3, figure 2. pK1 of H2CO3 is in figure 2. Please look at figure 2. CO3 2 minus species at pH 8.1. 8.1 is the pH of seawater. Could you check the percentage of CO3 2 minus in figure 2? Zero. At pH 8.1, no CO3 2 minus exists. This is the dissociation curve for ideal solution. But real solution, such as seawater, red curve shift to left lower pH. And percentage of CO3 2 minus actually, in seawater, this CO3 2 minus exists by about 10%. This is the real water. But for ideal water, you can find in textbooks zero. So this is the effect of activity. So if you search by internet the diagram, you can find another diagram in which the red curve shifted to lower peak. Maybe you can find in your internet. Please find later. Okay, next. Next is phosphoric acid. Dissociate in 3 steps. If you draw the dissociation curve for phosphoric acid, you can find that at environmental pH 4 to 10, this species is present. No H3PO4, no PO4 3 minus in our environment. At pH lower than 7, H2PO4 minus predominant. Same means that two species exist. Same percent. With increase in pH, HPO4 2 minus predominant. Because pK1 from the pK1 to 3 values, we can know the chemical species in our environment, depending on the pH. Okay, so that's all for the weak acids. Then I want to go into the next. Soil chemistry. Soil can absorb many chemical species, and absorption site is one absorption site is surface oxygen atom or 2-to-1 type layer silicate, such as monoclinic, vermiculite. Weak acid, functional groups of clays and humus, FiOH, LOH, FeOH, and COOH. The two sites are responsible for the absorption of materials by soil. Maybe you already know, but as you know, 2-to-1 type layer silicates such as montmorillonite, vermiculite, has permanent negative charge. Okay, can you look at figure 3? Figure 3. This is the calculation result by quantum chemistry. Pyrophilite, monmorillonite, and vermiculite. In case of monmorillonite, magnesium replaces aluminum in octahedral sheet. In vermiculite, aluminum replaces silicon in tetrahedral layer. And the charge on each atoms are calculated and shown in figure 3. In figure 3. Okay, could you look at figure 3? Surprisingly, the surface oxygen the negative charge on the surface oxygen is not affected by the isomorphous substitution, or 0.3. 0.8, 0.8, 0.8, no change. So this is the calculation result by a quantum chemical calculation. But this absorbs. But still so, the surface oxygen is the absorption site because they exist on the surface and negative charge. Then, for the heavy metals absorb on the surface of next functional group. Functional groups such as SiOH, LOH, FeOH, COH. SiOH and COH of humus has negative charge and has CEC. Usually, LOH and FeOH are positively charged and as AEC. And also, at a higher pH, they can act as a CC site. But SiOH, COH, never can be AEC site. Why? 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 The answer is written in figures 4 and 5. Figures 4 and 5. Please look at figures 4 and 5. Figure 4, SiOH. SiOH can dissociate to SiO minus. But at very low pH, SiOH also can be SiOH2 plus. SiO2 plus. At very low pH. But in our environment, pH of water is usually between 4 and 10. Then in our environment, SiOH cannot become SiOH2 plus or AEC site. In contrast, SiOH become generated at about pH 4. And increase with increasing pH. This means in our environmental pH, SiOH dissociate to SiO minus and can absorb cation. Next, figure 5. Figure 5, LOH. LOH, the blue curve, exists at all pH range. The LO minus, red curve, LOH, LO minus can generate at very high pH. In contrast, LOH2 plus, the green line, at pH about 7 or 6, LOH2 plus, positive charge can generate and act as a AEC site. FeOH is similar to LOH. So this is the difference between SiOH and LOH. Next, figure 6. Figure 6 is the COOH of fumes. COH dissociate from about pH 3 or 4, and the dissociation increase with increasing pH, just like acetic acid. So let's go to figure 7. Figure 7 is the ACC and AC of soil. Soil, figure 7. Because soil is a mixture of SiOH, COH, LOH, FeOH, and also 2-to-1 type layer silicate. Then CC increase with increasing pH. But become decrease with decreasing pH, but become constant. This is due to 2-to-1 type layer silicate, constant charge. In contrast, AEC, blue curve, increase with decreasing pH. This is a typical CC and AC of soil. Okay, so I want to go next. Next is absorption of cations. Uh, Coulomb attraction. Ionic size. Ion size is greater for potassium. But hydrated ion, hydrated cation. Hydrated ion is greater for sodium. Then negative charge. Okay. So could you look at figure 8? Figure 8. Because the ions is always hydrated, potassium can be close, can be attracted close. Then potassium is more strong attracted by the negative charge than sodium ion. Then potassium is more strongly attracted by negative charge. Then become increasing monovalent, divalent, and heavy metal. So in case of heavy metals, heavy metals is specifically absorbed by soil, clay, and you already know what is specific absorption. So you can study about specific absorption of cations and anions. In case of cations, heavy metal, Fe, and anions are phosphate and organic anion, are specifically absorbed by soil components. So, okay, I hurried up. Does anyone have question? No question?
Yeah, would you please to explain, Professor Matsue, about the figure 5, figure 5, yes.
Yeah.
About the ALOH. Is it ALOH 3, or would you please to explain? It means
figure 5 shows
yes. The blue, the blue line. The blue line.
Blue line. So actually, in clay, or more, some types of AOH groups exist. So I highlighted only this group
I see.
AOH. Of course, this group exists. Then I dissociation.
Yes.
So I just consider only the three species:
Yes.
neutral, positive, negative species.
Okay. Yes. Thank you very much. Yes.
Okay.
Okay, please continue. Sorry.
Okay. So the three chemical species, the dissociation curve is roughly, very rough.
Okay, thank you very much.
At lower pH become AAC site. At higher pH become CC site. Okay, thank you very much.
Thank you.
Soil or clay can absorb many cations and anions. For example, GC of monomer is about 1 millimole charge per gram. Or it's an old expression. Milli-equivalent per gram. 1 millimole charge per gram. About. One gram of monomer can absorb 1 gram of monomer can absorb 1 millimole Na plus. 1 millimole Na plus. Occupied surface area by 1 millimole of Na plus. How do you think? 1 millimole Na plus. Occupied how many area? Area means, for example, square meter. 1 millimole Na plus occupies 60 square meter. Maybe 60 square meters is greater than 8 meters, 7 meters. Very large area. 1 gram of molten molybdenite can absorb more than 60 square meters. Very large. Students, can you believe? Students, please answer to me. 1 millimole of Na plus occupies 60 square meters. Can you believe or not? Please answer. Release mute. Yes or no? Do you believe?
Please answer, students. About 1 millimole sodium occupy 60 square meter. 60 square meters. Yeah. Yeah.
This is true. For example, Na plus do you know 3 Armstrong? Do you know? Armstrong.
Angstrom, yeah. 10 point
Yeah.
minus 10.
What? 0.3 nanometer. G Na plus about water also H2O. Same size. This is about one sodium ion occupy this area. Then become 60. Become 60.
Yeah, yeah.
So actually, montomonite has specific surface area of more than 100 or 200, 300 square meters per 1 gram. Then montomonite can absorb 1 millimole of sodium. So now we should note that very large number, even 1 millimole, very large number.
Excuse me, would you please to yes, thank you.
Sorry.
You're welcome.
Very large number. For example, Small drop of water. Small drop of water. This is equal to 1 millimole. One millimole of water contains 6 by 10 to 20 water molecule. Okay, so the size of water. The size of water is about 3 angstrom. 3 angstrom is equal to 3 by 10 to minus 10 meters. Okay. The size of one water molecule, very small, very small. But the number of water molecules is very large. So then, if water molecules small drop of water molecules are arranged in one line, the size of one water, the number. Okay, this. How many? Sorry, kilometer. Kilometer. Okay, students, could you search your smartphone? From here to the sun. How many kilometers? By using your smartphone.
Sorry, Professor, I'm still confused.
From the
So,
sun.
yeah.
Please find internet. The distance from here to the sun. Sun, matahari.
Matahari, yes.
Matahari. Could you search by internet? Which is longer? Which is longer? Okay. Could you find? Okay. Could you find the distance until the sun is 1.5 by 10 to 8 kilometers. Long. Long.
Oh.
This means very small drop of water. By using the drop of water, you can go up to you can go to the sun.
Okay.
The size is very small, but the number is very large. Then one millimole. The number of ions or water or heavy metals, 1 millimole is very large number. So this is my final thing for the today's lecture. Thank you very much. We have another 3 minutes. Another example. The number of cells per human is very large number. World population do you agree the numbers? World population. Okay. The number of cells per human. Okay. Do you agree? Students, okay? Then half of the Avogadro number.
Yeah. Very interesting.
Avogadro number is very large. So this is my final lecture. Thank you very much. Okay, do you have any questions, students?
So please, all of the students, if you have any questions, directly to Professor Naoto Matsui. So please. Yeah, because I think very interesting for the basic principle of chemistry in general, and then about the relation to the soil chemistry? Yes. And then how about the relation to the nature? Yeah. So we can we could not imagine before that one drop of water, if we make a series of water molecules, so longer than the distance between us, the surface of Earth to the sun. Yeah. Very very interesting. And then
Maybe nobody in the world say this thing. Only me.
Oh, thank you very
A
much.
drop of water
Yes.
can go to the sun.
Yeah.
No one said. I search in the internet, but
Yes.
nobody said this one.
So this equation or original from Professor Naoto Matsui. Yes.
My idea.
Your idea very original. Yes. And then,
Original.
yes. And then we are the population of the world. Yeah. So also that 8 times 10^9. Yeah. So times by number of cells of people for every body. Yes. And then if the result is half of Avogadro numbers. Very interesting. Ya, luar biasa, luar biasa. So please, student, if any question about this today's material as the final materials or the fourth of materials from Naoto Matsui. Yeah. So please, Pak Rusli, you have any question?
Maybe I still confused for the soil chemistry, Prof. I will learn furthermore for the material. I'm sorry, but yeah.
Thank you very much.
But it's interesting. But the Avogadro numbers interesting for me, and the phenomenal for the soil chemistry.
So today's lecture was in English, then and my English is not so good. And then
With us.
the details of the today's lecture is described in the material written in English. Please study the
Thank you, Professor.
material.
Yeah.
And
Then
students,
please.
okay, students, if you have any questions, you can ask me by email. Yeah. Okay, Professor, please.
Yeah, okay. Because today is the final lecture for the series of lecture from Professor Matsui. So I asked to Professor Matsui, is there like it means the test or the for the student like or like homework also, maybe like summary of from the lecture from the first until 4, or would you please to give us? Yes.
Summary test examination.
Yes, for examination from you, if you have examination, or maybe for the examination from me. So please.
I did 4 times class. Then for the student examination, I will give Professor Nurtulis the the idea for the examination for lectures. Okay, I understand.
Yes. Okay. Okay. By this way, I will give examination to all of the student, and then I will give mark for them. It's okay.
Yeah. So I will give you the ideas for the examination of my 4 times lecture. Okay. Anyway, I will email to you.
Okay.
To
Okay.
you.
Yes, thank you very much. And then from your questions for the examination, and then I will deliver to the student, and then from student I will send to you for the evaluation. So very thanks.
Thank you very much.
You're welcome. Okay.
Thank you very much for giving me the opportunity for have a lecture. Thank you very much.
Thank you very
Yeah, but
much.
yeah, we are very thanks for the valuable
Very nice.
materials from you, because of it is, I think, the basics of the science. We still low. Yeah. So from your lecture, and then we also record, and then we can also continue for read, and then hear, and then from the video. Yeah. So we can learn more for your materials. So very thanks,
very much.
Professor Matsue.
Thank you very much.
Yes.
Yeah. Okay.
Okay, thank you very much. So we out.
Okay, okay. Very thanks. Thank you very much. And see you. And we hope that if you have time, please come to our university if you go to Indonesia. Okay. Ya, oke. Bu Erni, apa? Mungkin kita ini dulu ya, kita close dulu recordnya. Nanti kita mau bincang-bincang nih sama Bu Erni, gitu ya.